Hello boys and girls, I'm the Guide Knight and welcome to part 10.5 of my Godot tutorial. We're doing a breakout to the game. I'm calling this 10.5 because it's mostly bug fixing, and I decided to maybe make a separate episode out of it to basically do some debugging and look into the code a little bit more and think about some of the things we may have done like a little bit better. So first of all, I noticed that we still have like the blue bricks and the green brick. We're gonna get rid of those in the bricks folder. Second of all, last time we discovered like two bugs. One of them was this one, and the other one was this one. This amazing, basically null pointer exception or uninitialized object bug. Let's first try to figure out what to do with the first bug. Like, obviously there's something wrong with the way with our bow script, like when we actually do the bouncing. And let me first move this like as at the front, because we actually no longer do any other. Everything else we do is basically play with the AudoManager. And the bouncing is done here. So in one of the past episodes, I basically gave some wrong information about what the normal is. So let me try to fix this a little bit and go back to the drawing board. So basically imagine this like a surface you have, right? This is your surface, and last time I wrote this was the normal, but that's actually not the normal. That is the surface. The normal is, let me see if I can get like a blue vector here. This is like your falling vector, right? And the normal of the surface in that case is the 90-degree up from the surface, like basically showing where the outer like layer of the surface is. Like it is normalized, that's what it's called normal. It's normalized to the to have length of 1. And then if you would like to actually have a reflection, right? If you'd like to have this vector, this is probably how the bounce is implemented inside the Godot. But the formula is basically if this vector here is, let's say this is like P. It's like P. And then this vector here would be like N for the normal. Sorry for my bad writing. But basically it is, the formula of this vector is like, okay, so basically P and then minus, okay, I'm just gonna go ahead and erase that and simply type it in, right? So it's gonna be P, so P minus 2 times N, and then the dot product of P times N. So like if you don't know what a dot product is, basically it's multiplying every single like dimension with each other and then summing it up. So this is basically one number and this is a vector. So this is basically dividing this vector like modified by those like various variables, and then dividing this the result from the P. So that's a little bit of useless information, but let's see what we can do. Like we know our normal, right? This is what's important in order for us to get a good like reflection. In our case it's called bounce, but let's see what happens here, right? We click and instead of the bow bouncing in that direction, it bounces I don't know where. So let's go a little bit deeper and try to maybe use the debugging functions of this one, right? We can add a breakpoint here. It's called a breakpoint when you just click here next to this line 39. And if I start the game, it will stop here, but I would like to actually be able to move the window. So I will go here and on the window, I will check away the borderless so I can actually move it in Windows. and I'm gonna start the game. Press start, and you see as it hits it, actually, we actually can have some information about. Can we? It froze. I don't know. Okay, so basically we have the collision object here, and there is. We have the direction it's going in, so it's going up to the left. And fortunately, I don't know if actually there is a way to evaluate the values, so I'm gonna go ahead and just create a variable called normal, right? And the normal will be collision.normal. And we're gonna use that for the bounce to see what is going on here, like what can we do. Let me try to run the game again, move it to the side. All right, so now we are at line 40, like this is the green small play sign. Probably you cannot see it, but it's okay. It's normal, I would say, but that's the normal. So basically we have minus 0.9 and minus 3 and minus 0.39. So this means that we have some sort of this vector, right? Let me try to maybe get rid of those things or delete them one by one. Yep. Okay, maybe not this one. I can delete this. Yeah. So basically this means that we have like, this is our axis, right? This is the x axis, and this is the y axis, and this is plus, and this is minus, and this is plus. So we have minus, if this is like 1, this means that we have like x of 0.9 about here, maybe here, this x, and y is minus, almost minus 4. So like here, basically we have this vector of our normal, right? So the edge of that thingy here, of the brick, basically we hit, right? It should be pointing that direction, but instead it's pointing that direction. That's a little bit weird, and we need to fix that. So I figured a way to do it. It's a little bit hacky and maybe not the best way to do it. So if you have any better suggestions, that'd be really nice, and you can share them in the comments. I would really appreciate that. But basically what I figured is to do the following. Like we have the brick, right? This is our brick. And in the most cases, the normal is 1, like 0 for x and 1 for y. We can actually test that, but it's pretty sure, I'm pretty sure it's like that. This is the normal, and only the normals here in those edges are what's interesting for us. So what we can do is we can get the position where it hit, and if it's very close to the edge, we can assume it's an edge, and we can always apply the same normal, which we can say it's like that, right? We can kind of define our own normals for those 4 cases. So that's what we're gonna do. So maybe we can first like get rid of the breakpoint, and we can print the normal to see if this is actually correct, if my theory is correct. And the theory, I mean, I'm pretty sure, but so basically if we play the game, if we can play the game, unexpected constraint type int. Okay, so basically what is the I wrote 0 here, never mind. So like, except in those cases, like see that it's 0, 1, then basically that's what they expect, right? Let me quit the game. So this is what we expect. And in that case, we will need to have something that is similar to fixed normal, right? But we don't only need the normal, we also would like to see, because if you remember, we would like to like define the position where this hit, right? Because we have like 32, the height here is 32, and the width here is 96, right? I'm sorry for my bad writing, but it's 96. So if it's like 32.1 or 32.2, basically it's very close to the edge here. So we would like to have the position, like hit position. And this position is basically, if you remember in the past, we kind of already did calculate that. So basically collision dot collider dot global position. And then this is basically the position of the colliding object, so of the brick. And then we have to like get away, like subtract the collision dot position. So we can try to print that as well. I mean, one of the ways to have like breakpoint and see, but I prefer to have multiple data points. So for now, the fixed normal function will just return the normal. Fixed normal. Normal and then position, but position I'll add later. So return normal. So that should be all right. So let me... Okay. If we're hitting the brick, basically the position is all right, right? It is... But it's negative. So basically this thing is less than this thing. This is expected because we have to do it in reverse. So right now it should be fine. Yeah. Okay. So we can use this as our local brick hit position. So we can move this, I don't know, we can move it here. Maybe we only fix the normal when we're hitting the bricks because the walls have no like edges, right? But we can actually also add it directly here because we're not gonna go into that edge case here. So what I mean is like hit position is, we already saw that our normal has like some very rigid values like 0, 1, 1, 0, minus 1, 0, or and so on. So if either x or y is 1, as we know this is a normal, so the vector is of length 1, we know that the other dimension is 0 for sure. So we can just return the normal, that's not a standard normal. So let me just check that, like if normal x equals 1 or normal x equals minus 1 or normal y equals 1 or normal y equals minus 1, then we're gonna return normal. Nothing to change here, right? This is normal. In the other case, however, we need to make sure we fix it, right? We don't want to have like this wacky going to the upper left thingy when it should be to the lower left. How can we define that? Like we have the hit position, right? And then we can just check, right? If hit position dot, let's say x, the x, like we have like the, this is the x coordinate, the y coordinate. Like for it to be like in the upper left corner, we need to have x that is minimal, like 0 or 1 maybe, and y that is also minimal, so 0 or 1. So let's try to do this, like if x equals like less than 2 and hit position y is less than 2, then we would like our normal to be equal to vector 2. So we're in the upper left corner, right? So we need it to go diagonally to the upper left side. So this means that our x should be minus 0.5 and our y should be minus 0.5, right? So we do similar things with the rest, like else elif hit position. Let me just copy that and I'm gonna just fix it. And I can also add some comments here to make sure, like upper left corner. Then we're gonna do it the upper right corner. The upper right corner is like when the x position is greater than 94, right? We have like our bricks are of size like 96, and if we have like something that's greater than 94, and x and y should still be minimal, right? So we're in the upper right corner. In that case, the x should be 0.5 and y should be minus, because we're going up still, right? We're going to that direction. We're gonna do the same thing here for the lower right corner and for the lower left corner. So if you don't understand what I'm doing, it's a bit of a hack. As I said, I'm basically writing the normals by hand, which is the only thing I could actually come up with. Okay, so like if x is greater than 94, we can of course still use the values, right? Maybe we're gonna fix it in a following episode, or we're just gonna leave it like that. I don't really know, but for now it's all right. I mean, you get the idea, right? In the corners it doesn't really work. So we're to the lower right corner. In that case, this should be greater than 30, right? Because I think it's 32 that is the height of the brick. So lower right corner is like to the lower right. So x is positive and y is positive, right? And in this case, it's the lower left corner. So x is small and y is big. So bigger than 30. In that case, we want to bounce in that direction, which is actually our original issue, right? In that case, we need to have minus x and positive y. There's one more thing. In order for this to work, we need to normalize the normal, right? We kind of like freelanced it. We can probably check the exact location. We need to specify it's probably 0.9 something, or I don't know, to be of length 1. But we're gonna just use the normalize. Right? And then return the normal. In other cases, maybe we don't need to normalize it with some weird cases. So let's see if this actually did something, right? Okay. Non-existent function normalize on vector 2. I think it's normalized D. I did miss the D. Alright, so we no longer hear this weird effect, right? And it still looked okay, right? Not the best, I guess, but okay. So I guess we can live with that. I'm fine with that. Alright, so now let's go to our other issue, right? By the way, feel free to remove those magic values and replace them with something more suitable. But at least for now this seems to work, right? You can also move it inside the brick directly because you don't have a problem with the wall and so on. But we have a problem with our AudoManager, right? And the problem is, let me go again here and try to recreate the problem. Yep. Attempt to call function setStream in base null instance on a null instance. So what does this mean? This basically means that we are initializing it once, and once we load the... Basically, once we reload the level, I think, do we reload it from the get tree change scene? We're basically reloading the level here. This is no longer code, right? This is only code once. So we need to have something like initialize function, right? Let's go with the name and just create it. Initialize. And what are we gonna do in the initialize? Like, we want to actually move everything from here. Well, not everything, right? We just want to move the initialization script here, and I can do it. That would be awesome. Okay, so we now have a bunch of variables up there that we initialize here. What's it saying? Spaces. All right, I have space here. Not good. All right, so if we initialize right now, do you think that's gonna be enough? Don't know. Let me just check. First of all, we need to call it, right? So before we attach it, we need to initialize the manager. So let's see. Would be enough. It appears to be enough. That's great. But there is one more thing that I would like to do, and that is get rid of all this ugly code there, because I found it a little bit horrendous, like all this copy pasting. That's not a good practice, guys. So I'm gonna go ahead and just create a dictionary, right? And I can just call it audio dictionary, or audio dictionary, dict for short. Basically, dictionary is an object that can hold keys and values, right? So in our case, this dictionary is gonna contain the audio mappings. The key will be the sound type, right? Basically, we would like to have map the type of sound to the values we need for this type of sound. So the value will be an array. We can actually go with another dictionary, but we're gonna go with an array because we only need 2 values here, right? And the first value of the array, let me do it like that. The first value of the array will be the audio stream player. Like that case DOS, right? This is the first value of our array we want to add, and the second value of our array would like to be the file path to the audio file. I think this is all we need, right? This is all we actually need. So we're gonna go ahead and initialize our audio dictionary inside the initialize function. And you can assign it like that, like we basically have our sound type here. And I'm gonna go ahead and initialize the hit brick. So for our hit brick key, we need to add the hit brick audio and the hit brick file, right? So just add an array and the hit brick audio followed by the hit brick location, right? The path to the WAV to the WAV file. So let's go ahead and do this for the other ones as well. Hit wall and hit player. I can assign it like that. Hit wall and hit player. And just like hit wall and hit player. So in that case, here actually in the attach sound, I can get rid of that as well. And I'm just gonna go ahead like use the if audio dictionary type. I'm just gonna perform an action only if there is something found in the audio dictionary for this type, right? Not equal null. In that case, I'm gonna create the current audio. Var current audio is equal dictionary audio dictionary type and then 0. I'm not gonna do a lot of checking if there is an array of type of like length 2 and so on. I'm just gonna go ahead and assume it's like that. Maybe it isn't, but who cares? In our case, nobody, I guess. I don't know. So, and then I'm gonna go ahead and initialize the file path. Right. In that case, it's audio dictionary type and 1 because this is like the second element in our audio dictionary. Then I'm gonna go ahead and add it to the node, not add child. Current audio. And then initialize the audio file. Load the audio file path. And then just current audio set stream audio file, right? That's all we need to do. We can get rid of this. And then for the play sound, we also need to do a similar thing. Let me just copy it here. Like, but it's much more simple, right? We just need to get the current audio and then just play it, right? With the offset. Of course, I did that in the wrong place. Never mind. So I can also get rid of this, right? So right now, we have our dictionary, which is initialized in our initialize function. And then we can match any type of sound, and we can actually extend this with more sounds. And basically, if we extend our sound type, this will work without us adding anything more. But let me just test it first. Okay, there's hit. All right, this is wrong. My copy and pasting skills are not what they used to be, guys. Okay, now let's go. All right, it appears we have all our sounds initialized and up and running. So I guess this concludes this medium, I don't know, like 10.5 part of our Godot tutorial. And stay tuned, guys. Maybe next time we're gonna add some like menus and basically close to get closer to completion of the tutorial. I'm not even sure if I'll do some bonus parts for now, maybe. But anyhow, stay tuned. I hope you liked it. If you did, give me a thumbs up, and hope you did learn something about debugging and whatnot. And that basically is a learn-along tutorial, so we learn, make mistakes, and then fix them, because that's how real people operate. Alright guys, have a nice whatever you're having, and continue to stay awesome as I know you are. Bye bye.